There are four important properties of criteria of a good estimator of a parameter. That means if a parameter is a good estimator, then it must follows four important properties. What are the four properties? Number one, unbiasedness and minimum variance. Number two, consistency. Number three, efficiency. Number four, sufficiency. These are the four properties. Now come to the details. First, unbiasedness and minimum variance. Suppose capital T is a parameter. If sampling distribution of T has a central tendency towards theta. What is central tendency? Central tendency means obviously a mean here, because it calculated from mean. If sampling distribution of capital T has a central tendency towards theta and a small distribution, a small dispersion calculated from standard deviation, then capital T should be unbiased. Come again, capital T should be unbiased, because capital T denotes parameter here. What are the condition of unbiasedness? Expectation of T equal to theta. I repeat, if a sampling distribution of a parameter T has a central tendency towards theta, central tendency means mean in bracketed, and a small dispersion calculated from standard deviation, then T should be unbiased if expectation of T equal to theta. And what is the condition of biasness? Biasness is equal to expectation of T minus theta. And if we denote another estimator which is T prime, then T should have a minimum variance if it satisfies the following condition, which is variance of T less than variance of T prime, whatever be the true value of theta may be, because we denote expectation of T equal to theta. Theta is some specifically constant, whatever be the true value of theta, it doesn't matter. So we in total, if we sum up again unbiasedness of minimum variance, then if parameter T has a sampling and its sampling distribution of T has a central tendency towards theta and a small dispersion, then T should be unbiased if expectation of T equal to theta, and in bracketed bias condition of T equal to expectation of T minus theta, and T should have the following smallest variance if we consider another estimation estimator which is T prime, if variance of T less than equal to variance of T prime. This condition can also be termed as minimum variance unbiasedness condition. Minimum variance unbiasedness condition. Whatever be the true value of theta may be, the value of T doesn't hamper. Next, consistency and efficiency. Suppose statistic Tn, T suffix n, it not shows here properly, Tn should convert stochastically to theta. It is given in both NG dash and Gungupta. Tn, T suffix n converts stochastically to theta. You know about convergence in your math syllabus and others. As n tending to infinity, given two positive quantities. Suppose coming and given two positive quantities which is epsilon and eta. I repeat, total one, statistic Tn, T suffix n converts stochastically to theta as n tending to infinity, n tends to infinity, and given two possible quantities epsilon and eta, however small, it should be possible to find a specific value of n. It should be possible to find a specific value of n which is n equal to n naught, depending on these two quantities epsilon and eta, such that probability in bracketed term modulus of Tn minus theta less than equal to epsilon, probability in bracketed term modulus Tn minus theta in mod close less than equal to epsilon bracket close greater than 1 minus eta. probability in bracketed term modulus Tn minus theta less than equal to epsilon bracket close greater than 1 minus eta, given n is greater than equal to n naught, that means a specific value of n. Statistic Tn based on the sample size of n is given with this property. With this property is called a consistent estimator of theta. Statistic Tn based on the sample size of n with this property is called a consistent estimator of theta. Next, it is efficiency. If suppose a sampling distribution, a parameter t should convert stochastically to theta, similar, it is very similar to consistency. Estimators are, if estimators are asymptotically normally distributed, and rapidity of the convergence can be measured at can be measured as inverse of variance of the asymptotic distribution, then the parameter is said to be, then the parameter t is said to be efficient. Parameter t is said to be efficient. Consistent asymptotically normally statistic having this property is called efficient. Parameter t is said to be efficient, and consistent asymptotically normally statistic having this property is called efficient. Lastly, it is sufficiency. A statistic is said to be sufficient estimator of a parameter theta if it contains all information of sample about theta. A statistic T is said to be sufficient estimator of a parameter theta if it contains all information about theta. That means estimator parameter is said to be sufficient because we all know everything about this parameter. If a statistic T exists such that the joint distribution of a sample, then T will be a sufficient estimator of theta. Joint distribution of a sample, then T would be a sufficient estimator of theta. These are the 4 important properties. Okay.